In this video, we're going to take a look at partial derivatives of the not so pretty. So we may need to simplify them algebraically. They may have exponential and logarithmic moving parts to them. And so you just have to be really careful and not worry about it so much. Let's just plod through and see what we can do with it. First one. This is a square root. It's got two different variables in it, x and y. And we're just going to rewrite that square root as an exponential, because then what that allows us to do is take the partial derivative with respect to x and with respect to y. With respect to x, y is just a number, and so we have an embedded function. We're going to bring this 1/2 down, rewrite what's inside, subtract 1 from the exponent. Remember doing that. So x squared plus y squared raised to the negative 1/2. Because we're a partial derivative, we also then have to chain rule out the derivative of what's inside with respect to x. So x squared with respect to x is 2x. Y squared with respect to x, that is just a number whose derivative is 0. And so you're done taking the derivative. You can simplify, divide out those 2's, and that will give you x over the square root of x squared plus y squared. Let's do this derivative now with respect to y. Still a function of y, so we're going to bring the 1/2 down, rewrite what's inside, subtract 1 from the exponent, chain rule out the derivative of what's inside. When we look at this guy, x is just a number, and so this is going to have a derivative of 0. We just take the derivative of y squared and get 2y. Now we can divide out those two, the 2 and the 1/2, and that is going to give us y over the square root of x squared plus y squared. Not pretty, still a partial derivative. Now for this one, we're going to need to do some algebraic simplification here first. The square root of x is x to the 1/2. So this guy is x to the 1/2 over x times y plus e cubed minus 17. But x to the 1/2 over x, this has an exponent of 1, and so when we simplify that, we get x to the negative 1/2 times y plus e cubed minus 17. This is what we're taking the derivative of. So our function's name is w. It's got a variable of x and a variable of y. So we are going to find the partial derivative of w with respect to x, where y is just a number. We look at the first term. Y is a number. It's a coefficient. Comes along for the ride. The derivative of x to the negative 1/2, bring the negative 1/2 down. X to the subtract 1, negative 3/2. Then the next term, e cubed, just a number, derivative 0. Negative 17, just a number, derivative is 0. So we're actually done with this. Now let's take the partial derivative of w with respect to y, where x is just a number. So go back up here and look again. Y is the variable. X to the negative 1/2 is the coefficient. If you had, say for instance, just 3y, the derivative would be 3, 17y, the derivative would be 17. So when you have a coefficient times y, it's a linear term. You just get the coefficient. So this just happens to be the coefficient. Not really pretty, but it still comes along for the ride. So the coefficient, x to the negative 1/2, because the derivative of y itself is just 1. Number with respect to y, that derivative is 0. This guy's derivative is 0. And so for as ugly as this guy may have seemed to you, once we rewrite it, we take that derivative, we get one that's not so bad, and one that just has fraction, coefficient, and exponent. Not a big deal. Now for this next one, we have a function of g, and the variables are x and y. You might want to think quotient rule, but because the numerator only has an x in it and the denominator only has a y in it, let's go ahead and rewrite that as x times 2y minus 1 raised to the negative 1. Remember, whenever you move anything in a fraction up or down, you change its exponent. And so we can move this up and make it a negative 1. Now, it's not a product rule, because the first derivative we are going to take, g sub x, is with respect to x, where y is just a number. And so y is a number. This whole piece here comes along for the ride. And the derivative of the x is just 1. And so all we get with respect to x is 2y minus 1 to the negative 1, or 1 over 2y minus 1. Now when we take this derivative with respect to y, where x is the number, now the x is going to come along for the ride, because he's just a coefficient. Then we have to take the derivative of this. We're going to bring the negative 1 down, keep what's inside, chain rule out, right? So let's bring the negative 1 down, keep what's inside. That's a y, sorry. 2y minus 1. Subtract 1 from the exponent to get negative 2. Chain rule out, derivative of what's inside with respect to y. Derivative of 2y is 2. Derivative of negative 1 is 0. And so you get this. Now we got lots of parentheses here. Let's go ahead and rewrite that. Negative 1 and 2, so we get negative 2x. And then this parentheses with the negative exponent, you can write it as it is, or you can go ahead and put it in the denominator, 2y minus 1 squared. You can make an argument that you want to leave it one way or the other. This lets you know that when you get a 0 in the denominator for this y, you're going to get an undefined fraction. So that may be a good thing to do, is to keep some variables if the exponents turn positive in the denominator. And it also tells you, regardless of what x is, your domain for the x is going to be all real numbers for this derivative. All right. I know lots of people are scared by exponentials, e's, and natural logs. And so we want to try to separate some things here. This first term, the 2 is a coefficient. The e raised to the 3xy is a variable term. Now we've got an e sitting out here, and there's no variable in the exponent, so this e is just a number. And then, okay, now we've got a base that's not e, it's 3, so its derivative is going to look a little different. So let's go ahead and walk through this. Take the derivative with respect to x. Y is a number. Go one term at a time. The 2 comes along. E to the 3xy. Keep the exponential. Chain rule out the derivative of the exponent. With respect to x, the 3 and the y are numbers, so a number times x. The derivative of a number times x is just the number. That's why you get 3y. Let's go to the next piece. E is a coefficient, so plus e times the derivative of the natural log of xy. So it's 1 over xy. Sorry, that's a multiplication. Multiply that by the derivative of xy with respect to x, and you get a y. And then that last piece, when you have an exponential whose base is not e, you get a derivative of the natural log of 3. Keep the exponential. Chain rule out. Sorry, I'm off to the side. Chain rule out. The derivative of xy with respect to x is y. This looks horrible. Let's go ahead and rewrite this. 2 times 3 is 6. Y. E to the 3xy. For the next piece, e and y, well, those y's divide out, right? Y and y. So we get e over x minus, and then this last guy. So we get y times the natural log of 3 times this. Order doesn't really matter. Some people always put the variable out front. Then they'll put parentheses around any exponential so you don't think that you have an extra piece in the base. Most people put the natural log or the log last so you don't lose that term. Okay. Let's go ahead and now take the partial derivative with respect to y. X is a number. 2 comes along for the ride. E to the 3x is a function of y, so we're going to keep the 2. E to the 3xy. Chain rule out, the derivative of the exponent with respect to y is just 3x. Plus, the e comes along for the ride. Derivative of the natural log of xy with respect to y is 1 over what's inside, times the derivative of what's inside with respect to y, so you just get an x. And then, sorry, this derivative of negative 3x to the y, where this is a base that's not base e, so we have to take the natural log, and there's a minus sign, minus the natural log of the base, which is 3, times, keep the exponential, times derivative of the exponent, and then derivative of that is with respect to y, because it's here. With respect to y is just x. Let's go ahead and rewrite this. 2 times 3 is 6x, e to the 3xy. And then we get some dividing out. X is going both of those, so we get plus e over y minus. We're going to do the same rearrangement of this last term. And, oops, almost wrote another sign. And so the x times the exponential, I just reversed the order to keep the log last. So this is the first order partial derivatives of this. You really, when you're working with these, when you see these exponentials, you have to just take a deep breath. You breathe in really slowly, breathe out really slowly, and then just take it one piece at a time, focusing on what the variable is and what the number is, and then walk your way through it. For this one, we're going to find all second order partial derivatives. So the first thing we have to do is find the first order partial derivatives. And when we do that with respect to x, y is a number. And so for the first term, y is a number, we get 2x times y cubed. The next term, with respect to x, we get 4x cubed y. With respect to x, the e to the y is a number, so a number times x, the derivative of a number times x is just the number. For us, the number is e to the y. Let's find now the partial derivative with respect to y, and x is a number on this one. So with respect to y, the x cubed comes along for the ride, and you get 3y squared. Let's put that 3 all the way out front. So look at that again, 3y squared, x squared comes along, so we've got that. For the next one, y is the variable because we're working with respect to y. The x fourth is a number, so some number times y, the derivative of the number times y is just that number, so you get plus x to the fourth. And then the last piece, you have an x, which is a number, e to the y, derivative of e to the y is e to the y. And so you get plus x e to the y. I'm going to draw a line here because to do second order partial derivatives, we're going to refer back to this term that's up here. And so we're going to take it with respect to x again. So with respect to x, 2 and y cubed are numbers. So a number times x, the derivative of a number times x is just that number. So we're going to get 2y cubed. Next term, with respect to x. With respect to x, we get, if you ignore the y, you get 12x squared, but the y comes along for the ride because it's just a number, so 12x squared times y. And then the last one, there is no x in this term, so the derivative with respect to x of that is just 0, so you can put plus 0 or just leave it. Now let's take the partial derivative with respect to y of the partial derivative with respect to x. Remember, when you're doing these, you are doing the left one first, partial with respect to x, then partial with respect to y. So when we take the respect to y x is just a number for us. And let's look at the first one. With respect to y, the 2x comes along for the ride. And so let's just write that. The derivative of y cubed is 3y squared. Let's go ahead and simplify that while we're at this term. Then for the next term, with respect to y, the x's are a number, so any number times y, the derivative of any number times y, is going to be just that number, so we get 4x cubed. And then the derivative of e to the y with respect to y is just e to the y, and we're done. Excuse me. Let's go ahead and keep going. Over here, let's now take the second order partial derivatives. Let's do it with respect to y again. X is just a number. And on this first piece, x is just a number, so the 3x squared comes along for the ride. So we get 3x squared. Sorry, that's an x. That just made that worse. And then the derivative of y squared is 2y. Let's go ahead and rewrite that. 6x squared y. Now let's take the derivative of the next piece with respect to y of x to the fourth. Well, x to the fourth is just a number, so the derivative of that is 0. You can put plus 0 or just keep going. Now let's take the derivative of the last term with respect to y. The x is a coefficient, so it comes along for the ride. So it's plus x. And then this is our simplified piece. Derivative of e to the y is e to the y. So this is your partial order derivative, second order, with respect to y. Let's go ahead now and find the second order partial derivative with respect to x. When we do it with respect to x, as y is going to be a number. And so go up here, y is a number. The 3y squared comes along for the ride. Derivative of x squared is 2x. So that gives us 6xy squared. And then the next piece, with respect to x, the derivative of x to the fourth. So you get plus 4x cubed. Remember, this is our simplified down here. And then this last term, with respect to x, you have a number times x. So a number times x, its derivative is just that number. So you get plus e to the y. That is your final second order derivative here, f sub yx. So go one term at a time. Yes, it is important to actually talk about what you're doing as you go. I think it is really going to help you keep your term straight. What's a variable, what's a derivative. So that's it. Hope you're having a great day.